All right. Let's look at the scoring guidelines. That one. Part two. All right. 2 points. 270 worth two, getting the correct answer 270, and then the integral is worth 1 point. Getting the answer 80, and if you got 80, you get 2 points. Part C, 414.285 was only worth 1 point. Okay, and that's including, what did they do? They did 300 plus 80 divided by 0.7, however you did that. Like, different ways to get that. But 414.285, just 1 point. Part D, worth 4 points, considering T prime when it changes signs. Getting this 33.013, considering that, it's worth 1 point. You didn't have to freaking find this T2. This is not a max. It's like I hate this justification because that's a max. It's not a min. And then just looking at 0 and 80 and looking at the signs, you know it has to be here. 3.806. That's worth 4 points. So just like, man, like, write some stuff down. Talk about the signs. You can't use the sign analysis like your T prime sign chart. It doesn't work. Okay. All right, let's go to the next one. 2015 number one, and then we got 2013 number one. Close these off. Okay, again, calculator problem. The rain. We've done this problem before. I kind of want to skip it. Whatever. This is rate in. This is a velocity in. This is a velocity out. 30 cubic feet at time 0. What's the total flow in? Total in. Integral of our rate in, 0 to 8 of R of t. Notice that I don't put the function, but I have to show this. You write this down. You write that down, or write down what you're typing in. Don't write math 9. Don't write math 9. Never write that. Like, this is fine. It's 76.570 cubic feet. Is the amount of water in the pipe increasing or decreasing at t equals 3? Well, if the total is our initial plus the total in minus the total out, that means the derivative of their total is just the rate in minus the rate out. The velocity in minus the velocity out. R of 3 minus D of 3 is all we need. Now, we're going to find the mins, so we might as well graph T prime anyways. And then we'll have just R minus D, and we can find R minus D of 3. So R, man, this just reminds me of the test that I made for you guys. Like, I spent so much time making that test. Minus D. It's a people cheater anyways. Minus quantity D, negative 0.04 T cubed, plus 0.4 T squared, plus 0.96 T. Graph. Well, pause. I'm just going from 0 to 8. Not from 0 to 300. Pause. On. Pause. 0 to 8. On is pausing. Graph. Oh, let's change our X scale again. On. Go back to an X scale of 1. 8 tick marks. 1, 2, 3, 4, 5, 6, 7, 8. Right? All right. Oh, great. There's only one sign change. That means that's got to be the location of a min. This is the derivative of the total. This is it's negative and positive. That's got to be the location of a min. Now I want R minus D at 3, and it's negative 0.313, which means the total is decreasing. The derivative of the total is negative. All right, min. I just showed you t prime is negative. You got to make sure you write t somewhere. That way they know if you write t prime what it references. Second calc intersect. T prime is negative from 0 to 3.271. And then t prime is positive from 3.271 to 8. Therefore, t equals 3.271 must be the min location. That's it. You don't have to even check values. Like a lot of, and when we look at the scoring guidelines, they're gonna have this candidates test, and they're gonna look at what the value is at 0, what the value is at 8, and what the value is at 3.271. They'll compare the three of them. But if you just do your job and do a proper sign analysis, you know that has to be the absolute min. You know you don't have to check an endpoint. You guys have a lot of practice with these checking endpoints and stuff like that. You have a lot of practice with knowing when you don't have to do it. Pipe can hold 50 cubic feet of water before overflowing. For T is greater than 8, water continues to flow into and out of the pipe at the given rates until the pipe begins to overflow. Right? But do not solve an equation involving one or more integrals that gives a time W when the pipe will begin to overflow. I don't even know how much water's in the pipe. T equals 8. Okay. And it continues to flow into and out of the pipe at the given rates. So you're just trying to figure out, like, when will the pipe overflow? Like 50. When will the total amount of water be 50? When is T 50? That's it. And you just have this. T of 0, which is what, 20? 20? 30? 30? Plus, you can go 0 to W of R minus 0 to W of D. Since things aren't changing, you don't have to worry about adjusting your times. Now, let's say you found how much water was in the pipe at the 8th minute or whatever. Well, then you could have just said like 8 to W, 8 to W. This is where you started at 8 equals 50. Well, that's fine. All right, let's look at the scoring guidelines. What is this, 2015? 2015. Two points for part A. 76.57 is the first point. And then your integral is your second point. Negative 3.13. You didn't have to find that. You just have to consider R of 3 and D of 3, and then, like, say it's decreasing. The rate in is less than the rate out. The rate out is bigger than the rate in. The derivative of the total is negative. Those are all fine. Part C, look, all this freaking candidates test stupidness. I know it's going to be at 3.271. I know it's going to be at 3.271. T prime is negative, then T prime is positive. Boom. This is a silly justification. Give yourself all 3 points if you just didn't even do any amount of water. They didn't even ask you how much. All right, I hate it. Part D, 30, 0W R minus 0WD equals 50. So 30, 0W. They just combine it into one integral. You know you can do that, but just be careful if, like, it doesn't work over the entire interval. So good. There you go, 9 points. And then the last problem we got to do is 2013, number 1. 2013, number 1. So let's go to 2013. Number 1. Another calculator problem. Gravel. Gosh, the gravel problem. Classic gravel problem. I've done this problem so many times. Gravel. G. Initial amount. Rate out. Velocities. This is the derivative. That's 100. Don't put 100t. Like that'll give you how many tons that have gone out. That's the antiderivative of the velocities, 100t. But anyways, what's g prime of 5? All right, well, this is easy to find the value, but then understanding what it means is when people have difficulties. So let's use our friend Math 8. Now, what am I going to type in? Like, what am I going to write as my justification and like my steps? I'm going to write what I see right here. You know, I am not going to say I'm typing in Math 8. I'm not going to do anything of the sort. I'm literally going to write what I see here on the calculator to find g prime of 5. So it's like, for part A, to get the correct stuff, I'm taking the derivative. And if you use x, it's fine. But like it should be t. 90 plus 45 cosine t squared over 18 when t is 5. Okay? And you get negative 24.587. What does that mean? Well, guys, this is where everybody loses a point. Everybody loses the point on the second part. They can get the value, no problem, but then they don't get the second part. Using correct units, interpret your answer. Okay, G is the rate in tons per hour at which unprocessed gravel arrives. G is a derivative. This, therefore, is a second derivative. This is a rate of a rate. I found a second derivative value, which means we are talking about tons per hour squared. This is tons per hour divided by hours. Tons per hour squared. This is the rate at which G is changing. This is the rate of change of this rate. And that's probably the easiest way to say it. You can say the rate at which unprocessed gravel arrives is decreasing by 24.587 tons per hour. Okay? You can say that, but you can literally just say it's the rate of change of the rate at which gravel arrives. They're going to talk about decreasing in the scoring guidelines, I guarantee you, and they're going to use like the absolute value. It's like the rate at which unprocessed gravel is arriving is decreasing at 24.587 tons per hour squared. But I don't know. Just don't make it hard on yourself. But understand that it's a second derivative. Find the total amount of unprocessed gravel that arrives. Unprocessed gravel that arrives, that's just going to be 0 to 8 of G, total in. This is the rate in. This will be our total in. We've done this so many times. They always have one of these questions being like, what is just like a piece of a total amount? You're not incorporating an initial amount. No. I know I started with 100 or with 500, but that's not part of this question. This is just the total in. $825.551. Is the amount of unprocessed gravel in the plant increasing or decreasing at t equals 5? Okay, well, you know, probably somewhere you should be writing t is, 500 plus integral of g minus the integral of 100. And then you're probably like, okay, t prime is g minus 100. This is how we're going to find maxes and mins. We're looking at the derivative and the signs of the derivative. We need to find t prime at 5. You can say t prime at 5 is I kind of want just this piece without the integral. Let's see what happens if I delete this. Hey, there you go. T prime at 5. So that's G at 5 minus 100. We also could have just graphed it and looked. Negative 0.1859, negative 1.859. Okay, it's decreasing. T prime of 5 is negative. All right, now probably should have just like graphed G minus 100 because we need to find when we're at a max. Rate problems. All these free response problems, guys, are like kind of consistent. Now, I feel like more recent years, they're starting to make it harder. They're starting to make it a little less consistent, which means you got to use like concepts and you just got to keep things in your brain of like, okay, what does a derivative do? What does an integral do? Derivative finds a rate of change. An integral accumulates things. It's like an infinite sum. How you can use them, stuff like that, you know. But if they're straightforward, then we'll be ready. I'm going from 0 to 8 again. It's a max right there, unless we change signs again. It doesn't. What is the maximum amount? Unfortunately, we have to find a value. All right, so max T is at, and I know immediately what the answer is right here. And I'm just going to explain why. It's the only candidate. 4.923. That's saved as X. Ready? Go back out. That's saved as X. 4.9, I think. Okay. So T equals 4.923. Y. T prime, and I have T prime somewhere, is negative from 0 to 4.923. And then T prime is positive from 4.923 to 8. That's it. You covered the entire interval. You know there's not another candidate. This is telling me that T is decreasing. The people who are grading this knows that like that. If you write this, they know that you know that T is decreasing. Then T is increasing. This is all you need. Now all you need is the value. So T at 4.923, I'm going to dot it so that I know to put everything in, equals 500 plus 0 to 4.923 dots of G minus 0 to 4.923 dots of 100. And let's find that. Now, I could, no, I'm not going to. Never mind. All right, 500 plus math 9, 0 to X of, it's annoying. I mean, I could have figured out how to plugged it in. Minus 0 to X of 100. Now, I'm not writing down X, I'm writing down the 4.923 just to type it into my calculator quickly. 635.376. All right, let's look at the point distribution for that. And then be done with this video. 2013 scoring guidelines. All right, so negative 24.588, negative 24.588, 587, or 587, I truncated. The rate at which gravel is arriving is decreasing by that. See, that's what I'm talking about. They like got rid of the negative and they say we're decreasing by this much, but whatever. It's the rate of change of rate of change. It's a second derivative, tons per hour per hour. That's tons per hour squared. Boom. We got 1 point for G prime of 5. Everybody gets that point. 1 point for the interpretation. Hopefully you can get that point. Okay. Total in B, 825.551. Boom. 0 to 8 of G. 1 point for the integral, 1 point for the answer. Part C, looking at G of 5, comparing it to 100. If you did G minus 100, that's fine. 2 points for that. I don't care that they have like, oh, G of 5 is this, and that's less than 100 rate. Rate in is less than rate out or something like that. This is simple. This is calculus. And now look at all this work that they did. The jerks. Sorry for calling them jerks. You're not jerks. It's like, why do this? Why find that at 8? Does it take that much extra work? No, it doesn't. But it's a little sloppy in my opinion. Okay, it's an easy thing. It's got to be at that. The derivative is negative and positive. It has to be there. 635.376. Come on. Like, why are we messing around here, people? All right, that's rates, man. Get ready for the rate. Oh, you got a tough rate problem on your quiz. See how you do.